4G nodes for Algebra 2 Trig, solving systems of equations. Example 1 is we have the top equation is a quadratic. You see x squared is quadratic. The bottom equation is linear. There's no square term. So when you're solving having a quadratic and a linear, the easiest way to solve it, there's multiple ways to solve this, but the easiest way, I believe, is to use substitution. So, to use substitution, you should solve one of the equations, solve for y. One of the equations. You can do both, but I think the easiest one would just be to do, I tend to do the linear equation, so that x minus 2y equals -4. Subtract x divided by -2. And to simplify this a little bit more, yeah, so -1x over -2, which is the same as 1/2 x. 4 divided by 2 is 2, and 2 negatives would be +2. So I have y solved for. Now we need to substitute. Second, substitute. So we substitute what y equals in this linear equation back up into substitute in for y in the second equation. When you join these, use substitution, you join these equations together, you then will have both equations put together, which then you can solve for and get the solution. So 2x squared minus 25x plus 2 times 1/2 x plus 2. Let's substitute in for minus 76 equals 0. I'm going to get rid of the parentheses right away. We have -2x squared minus 25x plus 2 times 1/2 is 1 times x. 2 times 2 is 4. Minus 76 equals 0. Let's gather like terms. -24x is 72 equals 0. At this point, we can use, you can solve by factoring, you can solve by quadratic formula. I tend to go with the quadratic formula. So, I guess if you see that there is a GCF, you can factor out the GCF first. And the greatest common factor here is -2. Plus 36 equals 0. So if you factor out the greatest common factor, now your A is smaller, your B is smaller, and your C is smaller. They were, when we were up here, the A was going to be -2, the B was going to be -24, and the C was going to be -72. If you factor out the greatest common factor, your A, B, and C are smaller, and you still will get the answers. So, the reason why I did A, B, and C, yes, I should go back and talk about that. When I got all my like terms together, I had an x squared term. Anytime you have an x squared term for your biggest term, you're going to look for the quadratic formula. So, solving using the quadratic formula, x equals the opposite of b, plus or minus b squared minus 4 times a times c, all divided by 2 times a. We need to practice this over and over again. You got to be able to do this real quick, real easy. 144 minus 144 divided by 2. 144 minus 144 is 0. The square root of 0 is 0, so it's plus or minus 0 over 2. Adding or subtracting, you're going to get the same. So if you split this up into -12 plus 0 divided by 2, that's the exact same thing as -12 minus 0 divided by 2. You're going to get the same answer, which is -6. So anytime you have this equal underneath the radical, the discriminant. Anytime that equals 0, you're only going to have one solution. So we have x equals negative 6. Well, you need to find the x value and the y value. So this is the x value, you need to find the y value. To do that, you substitute back in. So I guess I said substitute, and the third step should have been, or the fourth step, solve. So somewhere in here I should put a fourth step. And now the fifth step is to substitute back into either equation. Any equation. The easiest one that I usually substitute into is the one I solve for y. So the one I solve for y is right here. Y equals 1 half x plus 2. So we substitute that in. Y equals 1 half the x is 6 plus 2. Half of 6 is 3 plus 2 is 5. So my y value is 5. 6, 5 is my solution. Moving on. We have now two quadratics, so both of these are quadratics. Both quadratics. Now what I will use is, for when I say quadratic, you're going to want to use elimination. To use elimination, you are going to line up all of your like terms. So, top, you line them up a little bit better. Terrible job of. Got it there. Alright, so I lined up my x squared terms vertically. X terms, y terms vertically, my numbers vertically. And now what you're looking for is, we're looking to get the coefficients on one of these terms to be the same. So the coefficient of my x squared is, on the top equation is 1. Bottom equation is negative 17. Those are not opposites. Now my x terms, I have negative 4 and 32. Those are not opposites. Or I guess the opposites or the same, it doesn't matter. My y terms, I have a positive 1 and a positive 1. So you can get opposites here by multiplying one of the equations by negative 1. So let's just take this bottom equation, multiply by negative 1. Trying to get opposites. So that's the goal of elimination, is to get opposites. Multiply by negative 1. So to do that, I'm just going to copy down this top equation again quickly. And the bottom equation, I distribute in this negative 1, I get a positive 17x squared minus 32x minus y plus 17 equals 0. When I have opposites, I have a positive 1y and a negative 1y. We can just add. So we're just going to add vertically. 1x squared plus 17x squared is 18x squared. Negative 4x minus 32x, negative 36x. 1y plus negative 1y, those cancel. 1 plus 17 is 18, equals 0. At this point, now we have a quadratic equation. You have a single quadratic equation, we can solve using the quadratic formula. If there's ever a GCF, take it out. So GCF, there's the greatest common factor. It's 18. Let's take an 18 out. X squared minus 2x plus 1 equals 0. So here we can use the quadratic formula. We can factor. Last problem I showed you the quadratic formula, so this one I'm going to show you how to use my factoring. So we have the greatest common, or the coefficient of the x squared term, the a, is 1. So we can do 1 times what is the last term, that'll add up to the middle, and that's negative 1. Negative 1. So let's break down to x minus 1, x minus 1. Take these factors and set them equal to 0. 18 can set equal to 0 only the factors with variables you set equal to 0. They're the exact same factors, so it really doesn't matter. You don't have to set them both equal to 0. So the x term is going to be 1. So if my x is 1, now we got to figure out how to get y. So substitute into any equation that has a y. So go back up to the start, and let's look at which one of these I would want to solve. The top one has less subtractions in it, so I'm going to use that one. Really no rhyme or reason to it. So I have x squared minus 4x plus y plus 1 equals 0. Let's substitute in 1. That's pretty sloppy. So, yeah, so we have 1 squared minus 4 times 1 plus 1 plus 1 equals 0. Substitute y. My bad. This y's got to stay y, so that's got to be y. I don't know what I'm doing. It's on break, right? 1 minus 4 plus y plus 1 equals 0. That's negative 3 plus 1. So y's adding 2 to get y equals 2. So 0, 1, 2 is my solution. There is a third example. I'm going to save this for class. Come to class, we're going to practice those first two, and I will show you example 3. If you want to try example 3, it would probably be easiest to solve this with elimination. All right, good luck. If you got example 3, if you have time, try to work it out and see what you know. All right.